So that should be up. Can you see that on, is that visible for everybody? Okay,
We're
great.
good to go. Yep.
All right. So hello. This is the rapid fire tech tour of the Spritely Network Community Institute stuff, Spritely Institute for short, if you don't want to say 4 long words at once. I'm the CTO of the Spritely Institute, so that's me giving useful, productive bragging, right? So we are a nonprofit that is specifically here to work on basically improving stuff on the experience of individuals and communities on the internet. So as Craig correctly said, well, let's get to background, right? So my background is I worked on the ActivityPub specification. So if you use Mastodon, Pleroma, PeerTube, Funkwhale, like a whole bunch of like kind of the current generation of things that are called the quote unquote Fediverse. I'm co-author of that specification from the World Wide Web Consortium. So I worked on that, and that was great. But when ActivityPub ended, I basically said, oh well, what's all the stuff that we can't do yet, right? How do we handle when servers go down, people being able to migrate between different servers? How do we handle when basically better privacy, richer interactions, and a whole bunch of other things? And this led me to kind of discover this whole background of things called object capability security. And so I'm co-founding this institution with our executive director, Randy Farmer, who his work goes all the way back to the mid-1980s. Actually, before that too, but I'll shorten it to the mid-1980s, where there was Lucasfilm's Habitat. If you haven't never seen it, I'm going to actually suggest you go to neohabitat.org. There is an open source revival of this. This is from 1980 freaking 5. They made a online virtual world system that was graphical. That was the world's first kind of what we might call massively multiplayer game, right? And it ran on the Commodore 64. So if you know what the Commodore 64 is like, thinking of having a graphical virtual world running on that is pretty impressive, right? But it turns out they did a bunch of other things since that. So one of the other things that they did is they ended up having an organization that was called Electric Communities. And Electric Communities basically, what happened was I discovered all this technology as in terms of, oh my gosh, they already solved in the mid to late 90s. They had already solved all the problems that I wanted to be able to solve with a direction called object capability security. So let's go to the high level first, right? So we're talking here about the technology, and this talk is going to be kind of more low level. This is a user group of, I think, pretty techie people, so we're going to kind of take a pretty techie perspective. But we're hoping to build stuff that, well, not just hoping, we are working towards building actual high level user-facing stuff, right? And in this mock-up here, you can see that there are these various users chatting, right? Now we have a longer presentation that actually shows off some other mock-ups of what we're seeing here. But what's interesting here is that this application, this peer-to-peer user agent, it's fully peer-to-peer. There's no client to server. The core technology for this already exists, by the way. It was built, as I said, in kind of the late 90s. Spritely is in many ways kind of a revival and synthesis of that and some other technologies. But what's interesting here is that there's no central server. There's no central naming authority. So there's no DNS/TLS certificate authority type stuff. That doesn't exist. There's all just, it's fully peer-to-peer and fully distributed. And the technology to be able to build this, as I said, does exist. The lowest level of the technology, the not user-facing stuff, is what we call goblins. So goblins, and I know some of the people who are attending this, certainly Craig, are familiar with David Revoix, did this lovely artwork for us of our goblin. So goblins is a distributed, cooperative, transactional programming environment. I'm going to actually show it off live a bit, but that's a lot of words, right? So but I think that it may be actually understanding those words. It might be easier to actually see them, right? So for what you can think of as a kind of an entry point is that this is a distributed programming environment with distributed security that you can actually understand. It's object capability security programming is extremely simple. It just follows this. We have this motto: if you don't have it, you can't use it. So it's entirely about you holding on to and using a reference. So for example, up until recently, a car didn't decide whether or not you could drive it by scanning your face, right? You had a different way that you could drive the car, which is whether or not you had a key that you would insert into the car, right? So it's possible to build things that are not identity based in their security model, and there's a whole bunch further you can go in describing that. But the simplest way that you can understand it is that it's just argument passing. It's just ordinary programming. Object capability security takes the fundamental passing around argument references between procedures and objects that you're already familiar with if you're doing any modern programming language, and just takes that as its security model. And what we add is we add the ability to use distributed programming, where programming against remote objects, doing asynchronous programming against remote objects, feels exactly like doing asynchronous programming against local to your machine objects, which means that you can just write code, and that code is able to be distributed and secure. Like you're able to interact with remote objects. So for example, in this diagram, we have two machines, right? We have machine 1 and machine 2. And at the highest level, we see, there's just these two machines that are connected over the network, right? And if we zoom in a bit, let's zoom in the furthest, right? So at the furthest level zoomed in, we have this object. So these are not the names of users. These are the names of objects. We're just kind of personifying them at the moment. So the object Alice has a reference to the object Alfred, and the object Alice has a reference to the object Bob. Bob has a reference to the object Carol, and Carlos has a reference to Bob. Now, Alice has access to Bob, and Alice has access to Alfred, but Alice does not have access to Carol. Carlos has access to Bob, but Carlos does not have access to Alice, right? So these are, but you can think of these as like references within your scope, right? The scope of your procedure or whatever. But what we handle here is these things called VATs are basically event loops. So we have communicating event loops within the same process. So Alice and Alfred are on one event loop, and they're able to talk with Bob on the other event loop on the same machine, right? And these can be different processes, or they can just be different threads within the same process. And then over the network is where we see this partition. And you see that there's the illusion of Bob programming against Carol. Bob doesn't have to really think about whether or not Carol is local, same way Alice doesn't have to think about whether or not Bob is local. This thing in the middle is this thing called CapTP. It's part of OCAPN, the Object Capability Network, which we have. It already works, and we're working towards building as a specification, which is the thing that allows you to have the illusion of just doing distributed programming as if it was ordinary local programming, and preserves the security mechanics of that. Now, building all this stuff involves some kind of careful technical thinking. I'm not going to go too far into the details here, but this diagram was actually, it kind of borrowed and modified for Goblins' purposes. What's interesting is that if you've done most programming, you're familiar with the idea of the stack, right? You have this, you call a function, and then that calls another function, which calls another function, and things kind of go up and down there. That's ordinary programming, right? You have this set of objects that you're programming against, and that's kind of normal sequential call return programming. But in Goblins, we also support asynchronous programming, which is kind of more like message passing. So Goblins is in many ways both an actor model system and also a sequential call return system. But we're able to have something called transactions that run within the local programming, where if something bad happens, they just roll back automatically. It's all safe. And to be able to give you an idea of what this means, here is some code, and yes, it is in Lisp, which is in Scheme, which means there's lots of parentheses, right? So this is about 30 lines of code, right? This is a bank that's written that's securely. Here's the interesting thing. This code right here is just 30 lines of code, and yet you're able to have peer-to-peer distributed accounts where that is fully transactional, and you're not able to steal the money of other users on the network, and you're able to just and if something goes bad, if there's an error in this code, like if you were trying to reduce the number as in terms of withdrawing from one account and then increase it in the account that you're going in, and an error happens in between, the transaction is written such that it will automatically roll back. There will not be any corruption of state in the system. And this is just 30 lines of code manages to provide this functionality. Now, that code was kind of overwhelming. What about video games, right? So when I was working on the system, before I even worked on the distributed programming thing, this is a space shooter I built to test the system for myself. It's a space shooter that runs in your terminal. That's why it's called terminal phase. Runs in an ordinary developer terminal. That's pretty fun, right? And so I wrote this to, test for myself. Well, gosh, is this actually fun to program in? Can I build something interesting? And so you can see this is all ASCII art. By the way, you see these different stars moving at different speeds, there's not enough fine-grained data. By the way, I'm using Unicode character points to add parallax scrolling here to the stars. That's just a side thing for fun. But okay, cute, Christine, right? This is real cute. This is just a game you're showing me. We need to think about this for something more serious, right? Well, I mentioned that Goblins is transactional, right? And when I talked about there an error being occurring that you'd be able to just roll back automatically, right? Even more than that, actually, it's just that the changes that you have just are simply not committed. Well, what's the equivalent of unlimited rollback? Let's find out. So what if we run this game with this time travel feature enabled? So it turns out I programmed this entire game without even thinking about the fact that, oh, right, we have time travel built in. The unlimited amounts of of transactionality is time travel. And actually, I did not change a single line of code in the gameplay in order for this to work. This was all automatically exposed, or I just had to expose it, actually the GUI to the user so that they could select between the different states. But this is what Goblins gives you automatically, is the ability to become, a time lord and be able to travel backwards and forward in time. So here's another interesting demo that we did, which is called Goblin Chat, right? So here, wrote this little chat application over here, and look, it's a Tor Onion service address. Okay, that's a peer-to-peer network. So I don't know if you know, but Tor actually contains two things. One of them is this, privacy preserving thing, but actually the other thing is a peer-to-peer network, which are Onion services. So we use that to bootstrap and show off. You can have multiple network layers in which you could do things, but I want to show this off. Here's a little chat program. So what's interesting here is that this chat program, I wrote it before I even had the network code, before the network code even existed. And then once we added the CapDP network code, I actually just connected it to this, and all the code that I wrote to work locally within one process, just testing against it, it automatically worked over the network. So this whole system with both the code that provides the users being like them being able to receive their messages and stuff like that, and the chat rooms, all of that is only 150 lines of code for both the logic for the chat room and also for the users. But here's a really interesting thing. It doesn't even mention the network once. It does not mention the network once, and yet we're able to have a peer-to-peer, end-to-end encrypted system where neither user can impersonate the other user, written in 150 lines of code. And it's actually really nice to write this stuff. Maybe you're afraid if you're not used to Lisp, but it's actually very pleasant. So if you're interested in more, if you go to Spritely.institute and click on the Goblins page, there we have this thing that says a paper, and it's called The Heart of Spritely, and you can read this, and it's practically a book that explains like the core ideas of what our technology does. Now remember, this is very low level. This is the user-facing side. This is the programmer-facing side of things. We do have user-facing. This ugly chat demo is not designed for aesthetics, right? This was just designed to be for me to test whether or not this stuff worked, and it does. And so we're currently supported by a number of different institutions. We just launched recently. We're supported by the Filecoin Foundation for the Decentralized Web, Agoric, and NLNet. We are hoping to get other sponsors. If you know other people who are interested in supporting this work, we are a 501c3 nonprofit in the US. You can donate to us, and it is tax deductible. And we want to make the internet better for everyone, right? So in a moment, I'm going to go on to actual tech demos. But before we do that, I'd like to say thank you again to the Mug for hosting us. Thank you to Craig Maloney for setting up this thing. And I'd like to ask, are there any questions? And that questions pre-code demos. Craig, I'm going to let you pilot that.
I'm piloting it. I'm looking to see if there's any questions at the moment. I'm not seeing any at the moment. One thing that did come to mind is, so let's say you're doing a chat application or something like that. What is to keep someone else from jumping in to that chat? How do you get that all set up as far as network-wise?
That's a good question. So, for example, am I still screen sharing? It looks like I am. So what you could, right here in this demo, right, you see there's this address back here, right? This is the capability. So if you think about if you've probably what you're most familiar with is like, Google Docs link, right? It's that, they have that thing where you're like, oh, you can share this link and it'll give somebody else access, but it's restricted to only the people who end up getting that link, right? So only the people who get this link are actually able to access this chat room, basically. Now there are additional things you can do to add accountability and the ability to revoke and stuff like that. That are completely feasible, but nobody who hasn't been like, if you haven't shared this link, and nobody can just it's not possible to just brute force and start guessing links in this system. You'd be using up so much machine power that doesn't exist on our planet to be able to kind of try to brute force that. So the you're basically unless if you're given a link, it's just simply it's the if you don't have it, you can't use it type philosophy. So
Okay.
did that answer your question?
I think so. We do have a question in the chat here. So question is, and I'm going to read it verbatim. So if I understand this correctly, one could use this to turn a local program into a network program by adding some kind of library, which changes how the program is interpreted. Macro magic? Question mark.
Well, let's actually take a look at some of that. But the answer is that you're programming within Goblins from the get-go. Like if you're writing your program in Goblins' style, and in Goblins' system, then your program automatically can be extended to the network. But Goblins has its own. You can't just take any program in any programming language at the moment. It has to be something that's within Goblin. So we are working on stuff to be able to make this so that it's extensible to other languages. Agoric does actually have some of that in their own system. So if you look at Agoric's, they have an implementation of CapTP that does a whole bunch of the same things. And actually a lot of the people who work there are the ones who came up with a lot of the technologies that we're using here. So it is possible to port this to other programming languages, but the system that we're showing here, the technology that we have, you can't just throw any program at it. You have to write your program for specifically this style, and then it can be exposed to the network. But you can write very thin wrappers around a code that already exists, right? So you could write your whole code. And then you could end up exposing basically these Goblins objects for the things that you already have, right? And then you can make that available basically to the people that you would like by, kind of sharing around these URIs, and that allows you to kind of bootstrap a connection and then, get the other things that you need. Does that answer the question, I think?
Okay, thanks. So
cool.
There you go.
Great.
Any other questions before we get into the coding phase of this? I'm checking just to give some folks some time to tap the keyboard if need be, or figure out how to unmute, as usually is the case.
Well, once we get to the point where there are not questions, also I could show a live demo of me. I've been actually porting the terminal phase, which was originally written in Racket. So we have two programming languages for this. One of them's in Guile, one of them's in Racket, which are both schemes, right? But they're not as compatible as you might think. So so I've been porting things from the Racket version to the Guile version. And actually, just within the last 2 days, I finally got it. About 2 days ago, I got it so that I could print to the screen, and today, I got it so that I'm able to actually play the game in the Guile version. So I can show off kind of what the experience of doing live hacking on that, like to bring that to life, looks like using Goblins, if that's interesting. But yeah, it looks like a question came in. What was it?
The question is, the Goblins concepts take care of handling the arguments to functions and so on to make it so that they could be remote on another machine? Question mark.
Yes, the Goblins. I think the answer is yes. I'm not fully sure I understand the question.
Yeah.
Basically, what Goblins does is it provides when you construct these objects, and we can take a look at what those look like. It gives you kind of the illusion of a remote object being just like that. And with your own local objects, you can pass it to a remote object, and then they have the same thing where it's like invoking a local function or calling an object method of an object on your machine effectively. It has the same level of kind of similarity.
Okay. Very cool. A lot more questions are probably going to come up during the coding demo. So why don't we head on over to that if possible?
Okay. All right. Well, let's back over here, and actually let's switch to. I'm gonna open Emacs up over here. And what we can do is I'm going to actually just show you that there's nothing up my sleeve. Okay, so I have this thing that's called in my sandbox directory, I've got minimal curses render.scm. So all this does is it basically boots up the guile and curses thing. And what I'm going to do is I'm going to boot this up. And by default, what I set this up to do is just a few lines of code just for me to set up a little loop. Main2 is not even used at the moment. It's just a few lines of code, just less than 200, about 150, that just like basically just runs a little loop over curses. It makes it so that I can test, input coming in, right? Nothing too special, right? Well, a couple days ago, I was like, well, how far along am I in porting the terminal phase code to Guile? So let's kind of walk through the experience of what I did. So in terminal phase, let me actually just bring. I'm gonna show you it with a new file, right? So new terminal phase.scm, right? So what we have here with the terminal phase render.scm, we're gonna say, okay, well, this is pretty good. Here we have this thing printing, but we're gonna want to pull in Goblin stuff now, right? So I'm gonna do connect to Guile. Okay, that's gonna create a connection, which we'll be able to see down here. So this is a little REPL, right? So I can do normal scheme code stuff. I can do +1, 2, 3, and it'll just print that out. But I can also do stuff like I can print to the curses stuff on the screen, right? So I can do so this is actually more. This is probably not the best talk for goblins. This is more a talk that I thought would be fun for this audience. So let's say I say, okay, well, this is fun, but I want to see if I can print something to this terminal over here, right? So I'm going to say, okay, there you can do add character, and add character. Let me bump up the font a bit. Let's see here. There. So add character, and we'll do or actually even better. I'm going to actually pull up my code from the minimal phase renderer for reference, right? So here in this code, I say, okay, what happens on the do update thing? Well, it does this add string. So I'm going to put this in. So I've got this add string to the standard screen, new input, blah, blah, blah. So does this work where I can do, hello mug, and we'll put that at 1. And sure enough, it says hello mug up here on the screen. So I was able to blit that effectively to the terminal. Okay, that's fun. That's cute, right? But we want to see if the terminal phase stuff is actually working. So I'm going to move this aside to just take a look at what's happening in the terminal phase code I was writing, right? So I'm going to go to the new terminal phase, right? So I've imported this code, which is pulling in all the terminal phase code I was working on. And I'm going to say, okay, that's cute, but the first thing you need in Goblins is you need an actor map. So I'm going to do define am make actor map. And I can evaluate that. And then over here, I can see, oh, okay, look, I've got an actor map. All right, so what can you do with an actor map, right? So we could do something like this. We could say, well, let's make a greeter. This is what a greeter looks like in Goblins. So I'm going to say greeter, and we'll say become. So become is this thing that allows you to change the state. And I'll say, okay, well, what we're going to do is we're going to take our name so that the greeter can greet us. And then we have to do this outer thing as a constructor. This caret here thing here is a hard hat, right? So the that basically indicates as a constructor. That's just a convention. And we're going to say, well, when we invoke this thing, it's going to take your name as an argument. And we're going to say, okay, well, what we'll just do is we'll just do format, hello, :a. My name is :a, exclamation mark. Right, and this should be, for this outer thing, is again the constructor, and the inner thing is the behavior. And we'll evaluate that. Oh, it's catching that I forgot to put in the argument. So your name and our name. All right, let's evaluate that. And now we can do, you know what? I'm going to make it slightly nicer. I'm going to go to define or use modules, goblins, actor, lib, and bootstrap, I think. Is that it? Define define vat run. Spawn vat. Okay. All right. You know what? That's not helping at all. That works. Wow, I'm not doing a good job on this demo in the least. So, now you're probably like, wow, Christine, I don't know what the heck you're doing. All right, let's try this. Syntax. So what we can do, actor map spawn. We can take our actor map, and what we're going to say is we want to spawn a new greeter, and we're going to call it Alice. All right, this is what I should have done all along. And now we've got this local object greeter. So we can name that, define Alice. And then I can do actor map poke at Alice and say, we want to call this with Bob. And it's just going to say, hello, Bob, my name is Alice. Okay, that's kind of cute, although that was a very long-winded and not very easy way of getting at things, I think, for this demo. What we really want to see is whether or not our stuff in terminal phase worked. So, okay, I'm going to copy and paste this stuff in to make it easier. So this stuff right here, let's going to evaluate this and going to find out what it is. All right, now that you've seen that you can run some code, right? So the first thing that we've got here is we've got this level 1 tape. All right, well, we don't know what the heck that is, right? So let's look at, well, what's the level 1? Oh, this is actually the game. This is actually the level that we're going to play in terminal phase, right? Okay, and see all these characters in here and etc. All right, well, what can we do with that? So we've got, well, in order to make this level, we have to get a score tracker to keep track of things, and we need to set the number of lives, because those are the things the level expects. So we're going to spawn this level here and say we're going to pass in the tape, the store ticker, and the lives. So that the tape is reading this one column at a time in this game, and basically letting us just kind of slurp this thing piece by piece. All right, that's cute enough. But now I'm going to paste in some code I wrote that allows us to basically get what the current stuff is in the level. So I can call this pose infos thing and pretty print. And what we're going to see here is that this is actually describing what the player should be seeing on the screen. There's a whole bunch of terrain, right? And then there's the player's ship right here. Okay, it's kind of interesting. But what if it's hard to visualize all that personally, right? So what if we wanted to print this, right? So I'm gonna write a little function for that. I'm gonna say fine print print pose infos, and I'm not gonna bore you with what this looks like for me to enter this in by hand. I'm just gonna copy and paste it. This thing is going to do the same add character thing we did previously. It's gonna take that information. It's gonna say, okay, well, if it says its color is red, we're gonna return this red thing. If its color is yellow, we're gonna return this yellow thing. So we're just gonna add that character to the screen at these X and Y coordinates. So that should work. So in order to, and we want to print a whole bunch of those at once. So I'm gonna add another thing, this print pose infos thing. All right. And we're going to say, you know what, we need it to be at the relevant stuff to be able to go at the right speed. That's not important here. I'm just going to show you, okay, now that we've done all that stuff, the real thing that you want to ask is, well, can I actually see anything from everything we just defined here, right? Well, I'm going to say, okay, print pose infos. Oh, hey, look, it blitted out the game to that screen right there. Okay, that's kind of cute. Well, I want to be able to advance the level, right? Well, it turns out I can do that. I can do actor map poke, actor map the level, and say, hey, tick the level. All right. And then I want you to print the screen again. You know what? This is a not very efficient way to do this. Let's do it like this. What we're going to actually do is we're going to change our level handling. We're going to add some things so that you can, I'm just going to paste in the rest of this code because, if I had thought this through better, we would have done this from the beginning. Here's all the stuff I wrote last couple days. And we're going to evaluate that. And we see we've got this thing here. Well, I added something here so that we can, if it's got the end character, it'll just move this forward 1 frame at a time. Or it should. Of course, now that I am trying to demo this live, it's not doing it. Oh, there it is. So it's very tortuously moving this game forward 1 frame at a time every time I hit N. That's not a great way to move a game forward. But what's interesting is that we can actually just uncomment this thing, and hey, look, suddenly we have a game that we can play live. So this is the Guile version of things being played live in terminal phase. And what's kind of interesting is that building up a program often involves kind of exactly that type of behavior. So I'm going to disable updating the stuff on the screen like that, where you're kind of doing live evaluations of things and figuring out what you'd like as you go. Now, something I haven't added yet is, well, what if we wanted to be able to store the state and restore it? I haven't added time travel yet to this version. So I'm going to do this live. I've actually not, this is a very dangerous thing to do live. I have actually not written any code for this. So I'm going to do, so old game state, and I'm going to set it to F. So there is no old game state. That means false, or hound F means false. So I'm going to say, okay, well, what if I want to save my game state? What I'm going to do is I'm going to say, okay, if the user enters the S key, that means they want to save the game state. And what we're going to do, or how about let's actually add it as capital, just ST for whatever reason. And so that's going to save the game state. And what we can do here is we can do set the old game state to be. We'll do let's see here, core.scm. I think I just added this. It would be copy. Did I really not commit this? Only to embarrass myself highly. This is not my best talk, but hopefully it is interesting to see how Christine develops live. Goblin chat.
We do have one question.
Okay.
Using print post infos exclamation point, you added all the actors to the end curses scene. I'm not super familiar with the end curses terminology, right? And since you defined a behavior for the actors, you can poke them and cause their behavior to happen, which advances the game, correct?
That's right.
Okay.
So that's effectively what's happening, is that we're actually running the thing, and we're testing it live effectively. So normally you don't actually run this peek and poke. This is for kind of like, it's kind of like the reason I use those terms is that this is for when you're doing low-level testing of the system. So this thing I just added was copy vector map. Okay, that's what's happened. So I'm going to do use module goblins core. That'll give me access to it. So I'm going to do is I'm going to say, okay, set the old game state to copy the weak hash actor map. Oh, that's what. Okay. Apparently that was not running correctly. Oh, I am very deeply embarrassing myself. This is what you get for doing something live. Geyser .config Emacs modes geyser. All right. Why did I do this? All right. Set queue default. All right. So now I'm going to switch back to here, evaluate this, and I'm going to do, I should have copy vector map. Do I have it? How do I not have that? Well, Christine, you are making a fool out of yourself live.
It's all right.
So
we did have one question. I'm not sure how serious this is or not. Has this been ported over to Elixir quite yet?
No, you could, but that's certainly an interesting question. No, you could port a whole bunch of this over, but the main challenge is getting the transactionality right would actually be very difficult. So let's see here. So do we finally have copy actor map? We do. Okay, so I'm going to copy the actual actor map that we have. Let's see if this works. Copy Copy old game state. Wow. Okay. Unbound variable timeout. Connect to Guile. Okay, finally. All right, great. We've got this up. We've got this running. I can now save the old game state by hitting S. And what you will see is that in the old game state, we apparently have nothing because, well, congratulations.
Is that because you restarted the game or you restarted the scheme interpreter?
Oh no, it's because I didn't hit, it's because I crashed my system.
Oh.
Well, this is the end of the live demo apparently, because apparently I decided to be extremely live with this. And we all know what happens when you end up being extremely live with something. So possibly unbound variable copy Wactor map. That doesn't make any sense. Okay. Well, so I'm not going to show off time travel today because I was going to code it live, but apparently that was a dangerous thing to attempt on a call like this. When you did not actually test whether or not implementing a thing like that live is particularly safe. So you know what? There's one way to resurrect this. I'm going to try to not make myself a fool one more time. And if we can do it, we will all celebrate. What we will do is the evil way. Copy Wactor map. The main problem that I'm actually having here is something that I did with my paths to make this dangerous. So I'm going to do something completely dangerous. I'm going to do define Wactor map data WHT as being this thing. So this is the thing that you can do in Guile, which is says I'm a horrible person, and I am going to pull this directly out of this module that did not export it. All right, so we're going to pull that out. And what's the other thing that we need? We need make Wactor map like this, because these things are not exported intentionally. Make Wactor map. Now, make Wactor map. All right. All right, that evaluated. Now let's see if we can safely evaluate. Let's see if we can safely evaluate in the new terminal phase. See if we can safely do the copy Wactor. Oh my God. What happened? Okay. I'm giving up on that. So, Craig, you want to save me by telling me asking me other questions live? Are there no other questions?
I'm not seeing any other questions at the moment. Although
All right.
One statement was, don't forget T, not S.
Okay.
Oh, here we go. How or where does the system store the state so that you could roll back later?
Right. So what it's actually doing is it's taking the transactional heap, and it's actually just it's actually just storing it as a data structure. So we do have a separate thing so that you can be able to serialize these things live. We actually have a one that's able to serialize things where imagine you wrote a distributed game. You know what? Let's do that. Let me show you some motivation for why I did all this stuff in the first place. Okay. All right.
We do have one other question as well, which is, what are the current goals for Spritely Institute? What are the next steps after porting to Guile?
Right. So this is a much better question. That's actually along the lines of the things that I should be answering. The thing that is the next goals for the Spritely Institute are actually getting the developer version of of the peer-to-peer social networking agent stuff up and working. So we kind of have a multi-phase rollout that we're planning, starting with a very developer-oriented version first that allows you to safely run code you don't trust, and also be able to do kind of just peer-to-peer chat, kind of similar to what we had, but just cleaned up a lot. And in a certain sense, once you have the ability to run peer-to-peer chat you don't or code you don't trust, and you are able to safely run code you don't trust, is that you're able to add some interesting extension functionality. So in order to be able to get all the way up to the point where you're able to extend your system without having to so here's a broad contrast to the systems that we currently have today. So if somebody sends you solitaire as an attachment, like solitaire.exe or solitaire, the equivalent for some ELF binary for your Linux machine or whatever, and says, hey, double click this, right? Well, what's the security sense that you have today? Is that it would be completely unsafe to be able to execute that, right? But in Spritely stuff, it should be safe to be able to execute that in an object capability security type environment. So being able to run code that you don't trust is high on the agenda. And basically, over the next 4 years, we're going to be going from a developer environment type situation to a kind of a community-based rollout to and then eventually trying to get software that everyone can run. So we are moving from a very kind of developer low level on the stack side of things, with interfaces that are then very as an intermediate step aimed to be for developers. But then we're also working towards getting the technology so that you don't have to be a more hardcore technologist to be able to use it as kind of the multi-phase rollout of things. Does that make sense?
Yeah. How are other folks using Spritely at the moment, like the other organizations?
Right. So at the moment, the technology is very internally fooding, right? So we're moving towards using this for all of our internal communication at the moment. Um, the main place that one of the places that I'm hoping to get more rollout and use very soon is within kind of the geeks community. That's one of the reasons we did the port to Guile, is that we're hoping that more of our technology could be usable by that community. Um,
That's
uh,
GUIX, correct?
GUIX, yeah. So a lot of people think it's pronounced Gwix. It's not, which it's completely reasonable to believe that you would pronounce such a thing, Gwix, but that's not the case. Um, uh, um, yeah. So so that's kind of the next target community, I'd say.
Okay, very cool. So what about that makes it a lot more safe to execute that particular code? Like you mentioned, sending over solitaire.exe or something like that
Mm-hmm.
Via a mail attachment versus sending it via Spritely and Goblins and such.
Right. So what you need a safe tested execution environment, right? So you can think of this as, if you sandbox something, right, fully, you can run it without having to be, like, if you imagine you completely sandbox solitaire, right, and you ran it so that, imagine solitaire was a procedure like this, right? We did define solitaire, and we'll just pretend for the moment it says, we'll just do, playing solitaire, right? It can't do anything particularly interesting if we execute this function. If we ran it inside of an environment where Solitaire didn't have access to the file system or anything else like that, where it could reach out and grab it, right? So similarly, if you run a process on your computer where the process is actually sandboxed so that it can't do anything particularly interesting, then the process is actually unable to do anything interesting like touch the file system or access the network or anything. The problem is that sandboxing applications like that is very difficult for users. And one of the things that you really need to be able to do is to be able to kind of extend the thing live. So if you can imagine that Solitaire was this procedure in this environment where it could do nothing particularly dangerous, but then you could pass in things that might be interesting, like maybe you pass in the specific the display display window, and then you make a new display window in a more powerful environment to say, so here's a window for Solitaire. then Solitaire would only be able to read and write to that specific window, not to any other window that exists. And then similarly, if you ended up saying, okay, well, we're also going to give you access to, the high scores file, and then we're going to say, well, we actually open a high scores file and we pass it into it. So, we do open file, home C Webber high scores.txt or something like that, right? And we pass that in. If you imagine Solitaire is executing an environment where it can't do anything particularly dangerous, then it actually can't be able to pwn your system, basically. It can only access this file that you gave it, and it can only display to that screen. So that's interesting, but of course the challenge is making this type of stuff not painful for users, right? Being able to do it as a developer is actually something that's very well understood. Being able to develop the user interface stuff is actually the challenging stuff. Yeah.
Thank you. Any other questions out there? Here we go. The chat thing that you showed in the beginning with the link to join the chat was interesting stuff as well. Do you have a blog post or something showing how to run that, which you could link later, maybe in notes or whatever?
I do. Yes. So we actually have, it's called Goblin Chat. There is it exists in this repo, gitlab.com/spritely/goblin chat. I would, but as in terms of making all this stuff very available to people, that's one of the things we're trying to work on right now. So the old Racket stuff was really difficult to get people to up and run. You had to really use Racket's package manager and stuff like that. It may not sound like it as in terms of, well, moving to Geeks should make all this stuff easier. Well, one of the challenges with Racket's package manager was it was very difficult to be able to package things in other distributions. I think this is a pretty common problem with a lot of language package managers right now. If you've worked on traditional distros, you've probably experienced this. But it was particularly hard in Racket. One of the reasons we're starting to embrace Geeks for things is because of stuff like Geeks Pack, which allows you to very trivially like make a Docker image or something like that from a completely reproducible package. So it's completely reproducible and easy to hack on in as a developer environment. But if you want to create kind of a black box binary, thing like that anybody can run, anywhere, it's pretty easy to do that using the Geeks Pack that already exists. Yeah.
I know a lot of folks may not be as familiar with Geeks. Could you just do a quick summary of what exactly Geeks is for folks?
Sure. Geeks is pretty nice. So, and you can see I'm doing some evil things here as we're talking. Yeah. Okay. So the Geeks is basically it's like Git but for your whole operating system. So in Geeks, when you are installing a package, so have you ever had the experience where your system's like, oh, you really need to do an upgrade. So you're like, okay, I'm going to do an upgrade, and then you do apt-get dist upgrade, and then you come back and something went wrong in the process where your system's hosed, and now suddenly everything's messed up, right? So Geeks is really nice in that it's a functional package manager, which means that it basically turns your whole operating system into being like Git, where like if something goes bad, you can just roll back. It's very similar to Nix, if you've ever heard of that. The ideas are very similar. The main difference is that Geeks is also written in Scheme from like top to bottom, and also is much more hardcore about some free and open source software principle type things. But the big advantage is that having it all be in a composable domain-specific language means that you're able to do a lot of stuff live. That's you're able to do a lot. You're able to basically get these different layers to talk together very nicely. Geeks also includes a bunch of, because it's so easy to extend, which is kind of the main reason why taking advantage of a Lisp is powerful, is Lisp makes it trivial to import basically any programming paradigm into an existing Lisp that's already running. So that means that you're also able to, pull in, you don't need to have a whole bunch of different language configuration types, and your whole operating system is thus scriptable. So it means that there's all sorts of interesting extensions that people have been able to add very easily. One of the extensions is Geeks Pack, which I saw Craig linked in the chat. And Geeks Pack makes it so that you can just you can basically create these kind of from the package definitions. It'll just create either tarballs that are fully set up where they're basically statically. It's like you kind of static compile all of its dependencies, even if your particular project language doesn't support static compilation. Or you can make like Docker images and stuff like that. They don't yet have support for Flatpak. There's kind of no reason they couldn't. But yeah.
Excellent. Thank you. Are there any other questions?
I think we are not far away from having the, I've said it before, I would love to end this presentation with me making not a liar out of myself and adding the time travel live. All right, so that worked. Now let's see if I can evaluate this. Okay, now I can evaluate that. All right, now that I can evaluate that, can I evaluate this code that I tried to add to my live version of things? Oh, that's what happened. This was a mistake of me splitting this across 2 files. Let's switch back to this one. We're going to switch back to that and just have this vector map stuff at the bottom. Okay. All right, here we go. Now we can do this. So what we're going to do is we're going to do t. Let's try this again. We're going to define old state as being false by default. And then if we do t, if we hit the t key, what it should do is set the old state to be, God willing, copy actor map of the current actor map we have. All right, let's see. This evaluates. I hit T. It crashes. Why? All right. Another question while I continue to debug this live.
Just a comment that says that was great. A lot of great tech here, and I firmly agree with that. There's a lot of really cool stuff here. And I know it's a lot for folks to take in all at once. I mean, I've been following Christine for quite a while, and I'm still hanging on for dear life, trying to figure out a lot of this stuff.
Well,
yeah. Good.
Well, I'm glad that people enjoyed it. I'm sorry that the second half of things ended up becoming so ad hoc. I had actually not planned a second part of this talk, which is why I thought, maybe I should try doing this thing with the experiments just kind of live. And it seems to be. I actually think I got it. I think I got this to work. Let's find out. All right, so I can just reevaluate this, and it should start the game. So here's a funny thing about doing live hacking, is I can just, here's all the code for the state of this level and everything. I can just restore this live, basically, by doing this, right? And it just stores all that, does it live. So, okay, what I'm going to do, I added the code so that it will store a new this state live. So here's the scary part. I'm going to do restore with R, and I'm going to do set the actor map to be copy state of the old state. I'm going to do when old state. Save my life here. Okay. No, not copy state. Copy actor map. All right, let's see. Crashed again. All right. All right. Let's see. T to save. Oh, it worked. All right, watch. Okay. Here's the thing. I'm gonna hit T and save the game, and then I'm gonna suicide bomb right into this. Oh no, that was a mistake, right? I'm gonna hit R. I'm back. We did it. We did it live. It was a massive mess for me to get to this state live on this presentation, but sure enough, we have live time travel added to this program in kind of the most disastrous way possible, but we managed to do it. I feel proud of that. All right. Any questions?
I have a question. So is the state then passed around between all the various other, and I'm trying to come up with the correct terminology for this, but you've got basically the state is let's say you added a second person or something like that, and you wanted to play this game cooperatively or something like that. Mm-hmm. How is the state between those passed around with each other, and what's to keep someone else from going back in time and undoing all of your magnificent playing along the way?
Right. This is a great question. I'm going to, let's see if I can get this to work the way I'd like. So to be able to show off this idea, what I'm going to do here, so it actually can be, so multiplayer terminal phase is something I've been meaning to implement. And understanding how that would work is maybe is actually pretty well understood by looking at the time travel. So no, you don't actually have to implement all this live. So I just wrote a macro here just to make me showing things off easier. Normally, you don't do this aftermath peeping poke stuff. You actually normally do stuff within a Goblins environment that we're, this is just because we're kind of kicking things off one at a time to play with them, right? But normally in a Goblins environment, you just write some code, and the code, we'll pretend this run thing doesn't exist. This is, anything I do inside of here. So for example, if I do, the level, and let's see here, what was it? Pose infos. It was the, yeah, it was right here. So it was the get ticked. Tell me what all the objects are that that this level has that can get ticked. Oh, okay, actually it's a ticker. So that runs. I can do multiple things at a time, and I don't need to, again, pretend that this doesn't exist. I can say, okay, I'm going to do that, and I can do a map over. Here's the object, and so up here I was doing it manually one at a time, where I had to aftermap peek, aftermap poke. Your code normally actually uses this dollar operator to say, I'm going to do this sequentially. It's just in order to play around with things. It's almost like I'm poking at the transactional heap manually in this code I was showing off here, which is not normally how you write Goblins code. Instead, you use this dollar operator to say, hey, I'm going to invoke this actor, call return. So I could just do like this. I can say, okay, I'm going to invoke this every object with pose info. I'm going to do a map over that. And sure enough, it actually, it prints all that out. And so there's no need to actually reference the actor map at all, because it's kind of like spookily dynamically bound within the environment that it's running in here. So you don't normally need to think about the actor map as a programmer. The actor map is a very low level detail. So when I gave my presentation earlier, I showed this. I showed this screen right here, right? Which is this, you see these two machines and they have these vats. These vats are the event loops. The actor map is even more low. So event loops that contain actors being called vats is an old school object capability idea. One of the things that Goblins adds that's kind of new is this transactional heap. Other object capability security systems have not had a transactional heap before. That's a new addition in Goblins. A lot of our ideas we took from the E programming language. And what the transactional heap is you can kind of think of it as like, it's actually a hash map. And actually, I just wrote the code that can expose this. So when I pull up the, let me go to the, so I've got this copy code that I wrote. So you see that it does this thing. Pull the data of the weak hash map out of this thing. So I'm going to do that. And what you see is that it says, okay, I've got this weak table here. This is actually basically, this is actually the transactional heap. So I can actually do, hash, I guess, hash for each. I'm going to do lambda key val. And I'm just going to do pk, object key, and we're going to see what's in here, right? And it prints all this out. So look, these are the contents of the heap. We can see that there's this this bullet, and we've got this y, x. You've got, here's an object that's what's an interesting object here. So you've already seen off the level, and sure enough, the level's here in the heap, right? We've already seen the player ship, of course, that's here in the heap, right? All this stuff is stored in the heap here. The difference between actor map, peek, and poke, what they do is they both construct a transactional actor map that sits on top of the what's called the wactor map, the weak hash actor map. And it references the previous actor map. And that transactional one only gets committed if there wasn't an error during the thing that occurred. And that copy wactor map thing that we did, it's actually very simple code. It's all it's doing is taking the hash tables from these two things, and it's saying, okay, I'm just going to copy. I'm going to make a brand new one of this hash table. I'm just going to copy the stuff from the old hash table into the new one, and then make a new actor map. That's all I did, right? So that's what we did for the time travel. Is we just actually literally copied the heap that Goblins has. Now let's think about how would we add multiplayer terminal phase, right? So let's pretend we're going to add multiplayer terminal phase. So and uncomment the thing that allows us to actually tick again, right? Now I'm playing the game, right? Now imagine I'm playing this with Craig, right? And Craig and I decided that we both wanted to play this game, and the problem was that I wanted to be able to have my ship move without and imagine there's two player ships on the screen, right? And let's say my player ship moves up and Craig's player ship moves down, and like we were both trying to shoot at the same thing. On my screen it looked like I killed the thing, and on Craig's it looks like Craig killed the thing. What we imagine we wanted to add transactionality to, we wanted to take our transactionality feature and turn it into something where we're able to play this game multiplayer over the network. The first version that we could attempt to do is that Craig and I could both submit our inputs. Now imagine we hooked up capabilities so that we both run this simulated version of this game, right, on our computer. We're both running the same basic game code. And I hook up as the same way that I hook up the inputs of on the keys that end up controlling the ship can move up and down. I basically say, okay, I'm going to give Craig's going to send these things about what Craig wants to do. And when Craig says, I want to move my ship up, I'll say, okay, fire off the method that ship would normally have to move up, right? And when Craig says, I want to move my ship down, I'm going to say, okay, fire off the method that moves that ship down. Now, in order for us to both operate on the same tick, if we were going to make it so that it was like completely fair, both of this, and we're doing a cooperative game here to simplify kind of like, fighting over each other and everything. But, in order for it to not screw up, you might say, okay, well, we're going to wait till we get both persons' inputs. Well, that's too slow for a high latency network, right? If it was too long for me to get Craig's inputs over the network, then my game would just like kind of grind to a halt while it was waiting for information from Craig, and that would be no fun, right? So what we could do instead is we could say, okay, well, I'm gonna store the state right here, this state in the game, right? And then I'm gonna restore it back to it. I'm gonna keep moving back, right? This whole idea of moving back in time. So I could be optimistic and have my thing playing over here, and then when I get Craig's information, we'll rewind back in time and play the information Craig gave me of his ship moving. And we'll just replay all the inputs moving forward in time, and then we'll manage to actually get coherent stuff. So this is what that allows, is it allows me to optimistically move my ship ahead, but then transparently, this is actually, if you ever played like one of the emulators, like ZSNES that has like network support code, this is exactly what they're doing. They're doing a save state of the old game code we're going to save state the state where Craig and I last agreed on what we were doing in the game. And then when the inputs come in, we're going to secretly, without the user knowing, time travel back to the previous version of things. We're going to, jump right back in time, and then we're going to, basically play the game from with all the inputs moving forward, now that we know what both players' things are. So maybe it's going to turn out that with those two things, Craig is going to actually be the one who ends up killing the ship, but I will still have been able to move forward, and I won't see any jitter. I'll just see, I might see a little bit of jitter, but I won't have to see slowdown. My game can optimistically play. Now, the question is, can Craig move my ship? And the answer is no. Because if on my game, I've wired up the ability for Craig to run the simulated inputs of these movements, and on Craig's wired up the ability to move my things. We've allowed for a multiplayer game there where I'm only allowing Craig to be able to pilot effectively what I've given as the player 2 inputs, and Craig's only allowing me to pilot what Craig's giving me as a player 1 inputs. And neither of us is able, we're both agreeing that we're going to run this shared hallucination together. Now, so this idea of a shared hallucination, so this is an interesting topic. Right now, the most popular way that people are really interested in doing distributed anything is through blockchains, right? Blockchains are basically doing the same thing we just talked about here with convergent state, right? Shared convergent state, and how do you build a shared convergent world? You don't usually have to do that. So when you do this distributed chat program, there's no need to be able to roll back in time and then roll forward with a shared distributed state, right? Because I've got objects running on my machine, Craig's got objects running on his machine, and there's no need for convergence. It's actually just different objects talking to each other. It's only when we're needing to play a agreed upon thing with a shared sense of linearity where we need to be able to have convergence. Otherwise, it's more like email, where you just send a letter, or like even physical mail, right? Like I can send a letter to Craig's house, and Craig can send a letter to my house, and I can also talk to Craig, and I can tell Craig about an interesting idea, and Craig can consider it, decide whether or not Craig believes that, and I don't need to actually open up Craig's brain and install this idea. Craig can decide whether or not Craig thinks it's a good idea and whether or not to move forward with it. And communication, we have a decentralized world of Craig and I talking to each other, and we don't actually need to be able to force convergence in order for Craig and I to be cooperative in a distributed world, right? So that's kind of the difference in philosophy. Shared convergence, like the thing that I was kind of talking about, how you do multiplayer terminal phase, is something that you only need very rarely. Yeah. So any other questions?
Let's say that I'm a cheating bastard,
Uh-huh.
and I do something. So we're agreeing upon the world. I'm agreeing that you control your ship. I agree that I control my ship. But at some point, the world has to move. The little ships and whatnot that we are fighting. Is there a way for me to put my finger on the scale a little bit and have them move more toward me and more toward my fire path that's not necessarily agreed upon by your system as well, but that would I would somehow overwrite that particular state?
In the version of multiplayer I just described, how you could implement multiplayer terminal phase, it would not be
Yeah.
possible.
Okay.
Right? You could create a local hallucination for yourself where you believe things are moving forward, but I would be playing forward your messages, and I would just be ignoring that, right? I just wouldn't see it, right? Since we're both agreeing to do this convergent thing, it would basically be like you'd be like, haha, look at this cool thing I did, and I just would just basically not be doing it. I'd be like, Craig, what are you talking about? Like, I don't see any of that, right?
Okay.
Um, so again, this decentralized convergence, the convergence thing is very rare to even need that whatsoever. But in the version of things I just talked about, all you'd be doing is just basically you'd be having it would be like you'd be having a local hallucination. And it's like, cool, okay, Craig's over there having a weird hallucination, but the rest of us aren't seeing that, right? You can paint monsters over your glasses, but that doesn't mean that there are monsters in the room that everyone else sees.
Gotcha. So I was thinking, and it seems like this technology has gotten a little bit of interest in the fintech world and whatnot. And so I was wondering if there was a way for someone to force a transaction or something like that into the shared state.
So when we're talking about transactions, for the most
Yeah.
part, Spritely is not as concerned with fintech type stuff as other projects are. Like we're working with
Right.
Agoric and stuff like that, but I'm more interested in social systems, and finance is part of social systems, right? But it's
Right.
only a small part, right? Transactionality, when we're mostly talking about, we're talking about local transactionality, as in terms of, if an error occurs, it's automatic error handling and rollback, right? Closer to
Right.
like in SQL, you might have transaction handling. That transaction handling is a little bit different than the transaction handling that's, having distributed transactions, right? You could use this technology to do fintech type things. So what I mostly say is, yes, you could use Goblins to build a blockchain, and the only difference you can think about, having distributed actors that collaborate. So if you're, like in email, right? Like email is the oldest distributed social network protocol. Now it's not very good in how it's designed, right? Because it was designed for a world before certain security considerations came into play. But it still is a distributed protocol in a certain sense. And would it be better if you ended up having a blockchain? Probably not, right? Do you really need everybody's message that's being sent in email in order for your email to succeed or even be particularly more decentralized? Not really, right? Now, but it might be that in the case where you have two, if you had if you and I were agreeing on but there what you could do is you could take that same thing that I just talked about with the multiplayer terminal phase. You say, okay, well, what if we don't just wanted Christine and Craig to agree what the next thing that was happening, right? what if we wanted there to be, anybody was able to see whether or not Christine and Craig, who won, right, or something like that, right? And we wanted to make it more competitive. In a certain sense, it's closer to what fintech type stuff is. Like what's currently your account if you ended up having a distributed, globally permissionless thing. So I described having that mint that can run in 30 lines of code, and that's true. I can actually show it off live, and it hopefully I'm not screwing myself. Let's see here, Goblins. Let's see if I put it in the actor lib. Goblins, actor lib, mint. Oh, I didn't put it in the Guile version. It's in the Racket version. Actor lib, Goblins, actor lib, mint. Simple mint at RKT. So okay, here's a simple mint. So this code, it is possible to run this and to create a bank account that other people can have access to. But it's a little bit closer to like something like JP Morgan Chase, right? You get an account at Chase, and Chase is the arbiter of this bank account, right? Now we could do the same idea that we just did with this terminal face thing and say, okay, well, what if we wanted to make multiple people? What if we wanted actually it to be like 5 different branches of the bank? And you want to submit your transaction. And if 3 out of the 5 of the banks say, maybe one of them servers were flaky. If 3 out of the 5 of them say that this is currently your state, then that's your state. So you could imagine the same technology that we were showing off for multiplayer terminal face here, but for bank transactions. And in that case, what you're really agreeing on is the order of messages that are being accepted, but it would still be secure, right? All you're doing is basically getting, okay, what's the order of messages is in terms of what who's trying to do what. So what you could do is you could easily scale this up to a quorum by taking that same idea and just saying, okay, we're going to have these 5 arbiters, and 3 out of 5, that's good enough. But you could also take that same idea and say, okay, well, what if we don't want to trust those 5 banks? What if we want to actually make it global scale? And then you could add something like Bitcoin or Ethereum's, like proof of work, proof of stake type systems with their consensus model to be able to say, okay, we're going to make this globally sized in its scale. So I think that's all pretty. I think so it's completely possible to take this tech and apply it to blockchain style technology. And but really, I think people oversell what they think they need blockchains for. You really need blockchains in the case where you need a linearized series of messages that are global, right? Where there's global agreement on those things. But you can actually do a massive amount of global coordination with stuff like the actor model without needing global coordination. Like that chat program I demonstrated was peer-to-peer end-to-end encrypted, and it didn't need global coordination.
Right. There is one of an idea. Could one create actors of different types so that one person with their specific actor has a kind of role which only allows them to do specific things due to the defined behavior of their actor? In the example, one person could control the movement of the ship, the other person can control the shooting.
Yes, you could absolutely do that. So let's say I imagine we want to do exactly that, right? So so let's say I want to give Craig a capability to do the shoot while I do that would be a fun game, right?
Let's do something like Enterprise Bridge or something like that. Like
right. Yeah. So that we're splitting it up. Yeah, we could totally do that. I feel like this talk has really turned a corner once I finally got that time travel thing going. Then it was like not just watching Christine do awkward coding, right? Then it was like, oh, okay, something's interesting's happening, right? So what we really want to do, so we effectively want to handle, these are the different, up, down, left, right type things. So what we really want is we want to create, input for Craig, right? So let's define, Craig controls, right? And then we'll say become, and we'll say, okay, did I import methods? I didn't. So use modules, goblins, actor, lib, methods. So unlike what people think, method-based dispatch is not essential to actor stuff. So let's actually say Craig gets to control shoot, right? So we're going to do methods, and we're going to do, shoot, and what that's going to do is, what did I call it here? So handle input. So what we're going to do is, yeah, it's this. We're going to say shoot allows you to do $, level handle input, handle event, and that one is, I think it's space. I think it's actually just the space key. So space, right? And then we're going to add another one, which is, backwards, right? And then that one is, left, right? I think that's right. I'm going to move this aside so I can actually look at the code. Left. Yeah, okay. So that one's going to be space, and we're going to add left, and then we're going to add Christine controls, right? So this is Christine controls. And we're going to do, we're going to handle, right, and we're going to handle up, right? So we're going to do up, and we're going to do forwards, right? So we're going to evaluate these. And what I'm going to do is I'm going to do, okay, actor map. Let's use our run thing. It's a lot nicer. So I'm going to do run spawn Craig controls. Yep, and it says local object Craig controls. So I'm going to do define for Craig. Craig, this is just for you, right? And let's say I had a capability, like I had some sort of chat thing. Now, I didn't show off asynchronous messages. Instead of using $, which is what you use for synchronous call return, you use arrow for asynchronous. So let's say I had, Craig inbox, and I'm going to say, hey, here is some controls for you, and then I say, and then I hand for Craig, right? And then Craig gets this message, and so Craig now is able to pilot this, but Craig is not going to get the other thing that's on my machine, right? Or maybe this is Alice setting this up for me, and Alice wants to then send to me, for Christine, right? So she sets up for Christine. And then she says, and we're going to copy paste that same thing that she said. Where was it? For Christine's inbox, here's the controls tree for Christine. So this is going to be sent to Christine, even though Christine lives on a different part of the network. And only Christine's only going to get access to these specific controls. So Christine's not going to have access to reach into Alice's machine and touch the other things. So for the moment, let's pretend this is a turn-based game or something like that. We're going to ignore the latency thing, just to imagine that, let's say it's a machine that was running where, it was like a roguelike, like a board game or something like that, where you're like doing like one thing at a time, old school roguelike, NetHack style, right? Where you do one action at a time. All right, so now let's see whether or not, so if we do run, when Craig does, okay, for Craig's able to do, shoot, right? No such method shoot. What did I call it? Craig controls for Craig, spawn Craig controls. Did I not call it? Oh, screwed up. That was my mistake. Let's do this again. Live demos, everybody. For Christine, for Craig, handle event. This is what you get when you try doing things live. Here we go. That's what it is. I'm flustering myself by trying to do everything live. All right. This should work. All right, let's try it again. And I'm actually going to be even paste that in. Paste this in. All right. Finally, Craig. Is Craig able to run, for Craig? Shoot. And it's just going to say no op. Okay. Well, I'm going to actually do this. I'm going to do something really funny. I'm going to run this live with for Craig shoot and try to make Craig's going to actually shoot. No such actor with this ID. Craig controls. Okay. That's because I created a separate VAT for it. No such.
What's the distinction between VATs and whatnot?
Yeah. So VATs are different event loops, effectively, within different VATs, basically different VATs contain different objects. So that's what this thing here is, right? So whether or not these different objects are within these different VATs, whether or not you can use them as such. I think I confused myself potentially with this thing that I'm doing. So no such actor with this ID in this vat. Oh, you know what happened? It's because I time traveled back to before this existed. So what I'm gonna do is I'm gonna turn off the movement because
What exactly does that mean that you time travel before this?
Well, that's a funny thing, right? I created that thing in an actor map, and then I clobbered the actor map to before I had actually spawned it.
Oh, wow.
Normally, people do not end up actually doing live time travel in their programs while they do this. By the nature of us doing this weird time travel stuff, I'm setting up funny environments. So I'm going to do for Christine and spawn this. Okay, so now now I'm going to store a new state, which is this moment. All right. Okay, now we're going to do something really fun. We're going to do tick level. All right, this is going to be fun. I hope. Christine, does it work? Yes! Look, I'm shooting from the REPL. Craig, you're able to shoot from the REPL, right? Can you move up? No such method up. What was it called? No, wait, you just didn't have up. So this is actually demonstrating perfectly. You couldn't move up, but you could move backwards, right? Oh boy. So yeah. So you can move backwards. Wait, wrong number of arguments to handle event. I don't know what happened there.
So there's a suggestion. I think the left will confuse it because the greater than symbol counts as an extra argument.
Greater than. Yes, that's actually exactly it. Yeah, it's a typo.
It's a typo. Yeah, no. Nice. Trying to get my attention about
nice that. Catch. Nice catch. That was a great catch. All right, let's do this. Let's do this one more time. Right. So now you're getting to see what live development is like, and it's like really fun to do this type of stuff live, I think. All right, so we're gonna get back here. We're gonna set up.
That we're in the right spot in time.
I mean, we're in the right spot in time.
Talk stuff right there.
Yeah. So I'm gonna set these up again, just so that we don't confuse our Time Lord selves. Right. All right. We're gonna store the new state. It's stored. All right, we're going to, this talk has gotten really exciting once I added this, I think. All right, now, Craig, can you move backwards? You can, right? But can you move forwards? You cannot, no such method forwards, right? So, but can you move up? You don't have up, but what about Christine? Wait. Wrong number of things to event. I still haven't fixed it here. Okay, well, we can move to the right at least without having to do things. So we'll do a restore and oh geez. All right, okay. So we're gonna do right. No, wait, what was my things? It was forwards. I can still do this. Okay, so that still works. So what you can see is that Christine can do forwards, but Christine cannot do shoot. And this object, remember that Alice sent a reference to this object over the network to Christine, giving Christine access to this. But Christine simply doesn't have access to the thing that's called for Craig. There is no way. The system does not permit Christine to have access to that object. So there's no way that Christine can actually fire things off, because that's a permission that only Craig has access to. So yes, not only is that possible, I was able to show it off live. I think that was pretty fun. Okay, any other questions?
That's awesome. Any other questions, folks?
Here's a question for people. Do people, does anybody want to play a game like this? I think this is the right UX here, right? You just shoot things at the REPL like this, right? Very, very.
It's totally our type,
Yeah. This is how previously I made this a game that runs on the terminal, but it didn't really feel like you were playing it running in the terminal. Now it really feels like it. It feels like you're running commands to the command line, right? Oh man, that's good. All right, okay. It sounded like there was another whoosh noise. Any other questions?
There was just a couple comments, basically. That was great, good, cool demo. And we need to find back in our timeline before the board can find us.
Yeah, that's right. There's actually a bug here. This thing is not moving. It's supposed to move with the screen. It's not. So I actually need to figure out what's causing that. But we don't need to do that live. Anyway, other questions?
Questions, comments?
Oh, I actually do know what caused it. Actually, it's because I'm this code that's actually making this run, it's actually not using terminal phase's game engine, like normal event loop. I just coded this event loop live over the last couple days because I was just trying to see if I could print things to the screen. This is like the hackiest event loop ever. So it's actually only running, giving the objects a permission to actually tick forward. It's not giving them the signal that they might. There's a couple of other signals that it's normally supposed to run. So I could actually look at the let's see if I can find the old code. Level dot, this is the worst way to possibly program, right? So let's do devel, terminal phase, level.scm. Okay, here we go. And then we've got this thing. There's tick, pre-level advanced, post-level advanced. Okay, that should have run. Advanced level? I have no idea why that didn't run then. Oh well. Advanced level. I see. Okay. It's not important, but there's a specific reason why this thing is not moving forward. That's a bug that I will fix in a future moment. Other questions or comments? Craig, what's on your mind after seeing Christine do insane live hacking, including very boring and then much more exciting moments?
So here's one question. Is it also possible to take away access to objects from actors?
Yes, so that's revocation. It's actually very easy to program. In fact, let's make a version of a revoker live, right? So let's say we wanted to. Let's say we said, well, we don't know if we want Craig to have access to this thing forever, right?
I sure
So
hell wouldn't.
yeah, so what I'm going to do is I'm going to say, you know what? Let's make a. It's called the caretaker pattern. I'm going to call it a revoker, right? Actually, we'll make it even. We'll make it even. We'll make it even. So the general pattern is, instead of giving Craig access to the controls directly, we give Craig access to an intermediate object. So what we're going to do is we're going to make a revoker, which can change its state. So it's going to do, we're going to do actually spawn revocable pair. And what we're going to do is, you know what? We're just going to do spawn, the spawn revocable pair. And what we're going to do is wrapped object. What we're going to do is we're going to do define, and I have to use the cells thing. So I don't think, okay, we do have cells. So I'm going to do define cell revoked question mark, and it's going to start out as false, right? And then what we're going to do is we're going to define a, we're going to define something called a proxy, right? And the proxy is going to take, it's just going to take any arguments, and we're going to do if revoked, then we're going to say we're going to error. No, you can't, right? Something like that, right? We're not going to do it. Otherwise else, what we're going to do is we're going to apply $ to the wrapped object. We're just going to pass along all args. So this is our proxy object here. And then we're going to, and then we're going to do, and then what we're going to also do is we're going to define, actually we can just return the revoked. So what we're going to do is we're going to do multiple value return of the revoked cell, and also we're going to spawn the proxy so that it actually appears in the actor map. Okay, let's try this. So now we can do spawn. Let's do run. Spawn revocable pair. And actually, my run is not well set up for this. So instead of doing values, I'm going to do const. That'll be a little bit better. Spawn revocable pair for Craig, right? Okay, it says, okay, well, you've got these two objects now, right? So I'll I'll say define revoke Craig's access as being the car of 12, that first object, and then, you know, proxied for Craig is being the cooter. All right, so so that was just basically the car encoder is not important. That's Lisp terminology for grabbing the first thing and the second thing. All right, so now what we're going to do is we're going to do okay. So right now, Craig wants to do, you know, proxied. So instead of giving Craig for Craig, we're going to give Craig proxied for Craig, and it just does this no op here. But you know, we're going to say, you know what, Craig, we don't trust you anymore. Revoke Craig's access. Can Craig access it? And remember, that's basically just this revoked cell here. So a cell is basically just something that holds a value. So we're going to switch it to true so that Craig will be revoked. Now, Craig tries running shoot, and it says, no, you can't. Right? So what this object did right here, what it did, right? You know, good pronunciation, Christine. What it did is it actually interfered. What it set it up is that we're not going to hand Craig this powerful object anymore. We're going to hand Craig this intermediate proxy that will only pass along messages as long as we have decided not to revoke it. So this is the power, and this is just using lexical scope, right? This is just ordinary programming, but we've managed to compose a very powerful access mechanism. We can do more than this. So in the Heart of Spritely white paper, by the way, if you haven't read it, I highly recommend it. Worked very hard on it. So in Spritely papers, it's on the website. If you know what, I'm going to actually show it in the browser, even better. You can go to Spritely.institute. Here we go. And then it says, there's this part where it says, okay, Spritely Goblins distributed programming platform. You click on this, see some more cute David Revah images, and then it says, oh, read our white paper. So we're going to click that. Okay. So we actually have a whole tutorial here that shows basically an example of somebody creating a blog, and they're going to set up, and they're going to do this whole thing. They're going to say, okay, I'm going to create a blog that people can add things to. I'm going to choose to give access for this other person to write to it, but you know what? I actually want to be able to take away the access from them. I want to be able to do all this type of stuff. So it actually walks through this whole example, and then it has this really wild example towards the end. I really recommend is we say, okay, well, you know, so we not only are we going to give Lauren Ipsum is the name of the person who runs the blog, haha, is going to give Robert access to be able to become an editor of this thing, and she's going to hold him accountable. And the way that she's going to hold him accountable, now remember, this is so the opposite of object capability security is the shitty access control mechanism that Unix has. Oh, you might have thought that Unix was pretty secure. It's not. It's called using access control lists, which everybody knows should know these days are bad, right? Object capability security does the opposite thing. We don't look at people's identity. We, you know, if you don't have it, you can't use it, right? The car doesn't scan your face. But then you say, well, wait, but how do we hold Craig accountable, right? What if we handed out access to a whole bunch of people? How do we know when it was Craig doing the bad thing? What if we wanted Craig to be able to sysadmin our servers, and we want to say, okay, Craig, oh no, you installed a Bitcoin miner on the server. We're going to hold you accountable to that. What you can imagine is, what if you ended up actually writing to a log, and you say, every time that somebody uses this capability, same way we handed that proxy that actually would or would not permit things, we handed a proxy that will run the thing if it's not revoked, but it'll also write it out to the log saying, the person that I think of as Craig just ran this command, right? And then eventually we look through the history and we're like, Craig, you installed this Bitcoin miner. Sorry, we're revoking your access as a sysadmin, right? And now we're able to hold Craig accountable. So just by ordinary object programming mechanisms, right? And here we're using object not in like the Java sense. There's no class hierarchy in Goblins, but object in terms of like this thing that you have a reference to that encapsulates state. We have functional objects inside of Goblins. It's more of a functional programming paradigm than what you might think of like Java's object-oriented paradigm. But people get confused over terminology, so. But anyway, the thing is that just by using ordinary scope and ordinary programming, we're able to actually compose these powerful access patterns. And in the white paper, the wild thing that ends up happening is we say, okay, well, what if Robert, who's going to become also an admin, of this paper that Lauren can choose to revoke access to if she would like. What if Robert wants to go on vacation and Lauren's really busy? What Robert does that I think is pretty wild, and you won't see, there's no way to really to do this in an access control system, but you're able access control list system, but you're able to do this in our system. Robert sets up a capability that Robert gives to a student. Robert hears about this student at the local middle school who won a science fair project. So he reaches out to the student and the teacher and says, "I want you two to write an article and submit it while I'm on vacation." Now, Robert does not have to reach out to the person who set up the blog, Lauren, to set this up. Robert can just set up this code on his own machine without having to upgrade any of the code for this server. And Robert says, "Okay, I'm going to." So here to the student, Robert says, "Here's the ability for you to edit this blog post, but you can only edit this blog post, and it's going to be named as being by you. You can't change the author, but you can change the title and you can change the body." But this is some middle schooler, that's not good enough quality control. So the Robert reaches out to the teacher and says, "Okay, you have the ability to publish this paper," and so. Yeah, it's down here. Guest post with review. So, so you basically, so Matilda, who is a student, so the science fair post is given to both Matilda and Mick Speaker to allow them to both read the state of the post, but the editor is only given to Matilda. So Matilda is able to edit and author the post, but that does not give Matilda the ability to publish the post. The teacher has the ability to publish the post, but can't edit it. So the teacher and the student have to coordinate to both reach consensus that the post is ready to go live. Now, no blockchain involved, but these two people are having to coordinate to be able to so initially Matilda writes this post and says, "My name's Matilda, I'm 12, I won the science fair," and then the teacher's like, "You know what? You forgot to add a title, and you should make this more engaging. You should make it the story about you." So the student makes these changes, and the teacher says, "Good enough," and the teacher can improve it. Now, the teacher cannot change the student's post for them. They can only approve. The student cannot approve the post. Only the teacher can. So between the two of them, Robert has decided if the student feels like their text is good enough and the teacher feels like their text is good enough but can't actually change the text for the student, then the teacher can approve it going live. And between the two of them, they're able to reach consensus. And Robert is able to be on vacation, and this post is able to be made to the blog without Robert having to be there. But Robert is still held accountable for this decision by Lauren, who runs the blog. So if Robert had set up this thing and it wasn't a good idea, Robert would still be held accountable because that's who Lauren had chosen to hold accountable for Robert's access. But Lauren and the teacher, or the student and the teacher, do not have access to the more powerful things that Robert has access to. So anyway, those are examples of powerful composability that Goblins provides without having to be able to do any access control lists and actually being able to do more powerful things than object access control lists just via ordinary programming.
Awesome. Are there any other questions?
Is anybody's brain fully broken by this point in the presentation?
If you want to raise your hand just to hold up and let us know that you have any questions. If not, I'm going to
call it.
Not necessarily call it, but so one question I have. So in the case of the blog posts and that, the access controls are held where specifically in the system?
In the objects themselves.
In the objects themselves. Okay.
The object behavior is the stuff that defines that. Now, the question you might ask is, how's the stuff persist to disk? Because I've only shown off live runtime, right? Yes. So that we have a system called, it's currently codenamed Ori, but it's going to be a core part of Goblins. And what it does is so if you've ever, I'm going to say something really wild. If you've ever implemented a language before, there are these two pieces that work together, eval and apply, right? And you've probably at least run eval in some code, right? People might be like, "Oh, it's dangerous." Well, we can write a version of eval that's not dangerous. But in fact, I can show off my other fun demo, which is where we can. I have an an interpreter that's made object capabilities secure, and you can try to run what would be a normal guile, the thing that would wipe my home directory, but it can't wipe my home directory in the version that I show off, because it just doesn't have access to the file system permissions. But anyway, what was I bringing that up? Right, yeah. So if you write one of those things, you have these two pieces of an interpreter, right? One of them's eval, one of them's apply. And what eval does is it kind of gathers up everything related to the program that you want to run. It says, okay, I have to run all the little pieces, right? And what apply does is it actually just says, okay, I'm going to run this one function with the things that you told me I'm going to run it, right? And those two pieces work together. There's the gathering phase and then there's the execution phase, basically. What if you ran those in reverse? So this is an observation that Jonathan Rees made a number of years back to Mark Miller, who are both people I've highly collaborated with in order to be able to make this stuff exist. So Jonathan Rees said, oh yeah, I have this serialization system where it's called uneval and unapply. So instead it runs it in reverse. What if your program actually, all the pieces say, here's what I'm going to do in order to be able to run. But they can only say what they would like to be able to do the next time they're resurrected based off of the capabilities they currently have. So if you imagine making a distributed game, in your distributed game, imagine you added this this character who is like, somebody has like this fool who wants to be a king, right? The fool can put on whatever garb they want. They put on their little, their hat and all that stuff like that. But they want to have $1 million. They want to have 1 million gold coins, and they want to have a scepter that allows them to vanquish anybody instantly. But they weren't given access to that authority, right? And we as the game designers want our game users to be able to play this world, but we don't want them to be able to have access to these things that they weren't actually handed, right? Maybe they can control how they look, but they don't have access to mint currency, and they don't have access to powerful scepters that they don't have, right? So what in our safe serialization system, kind of like how you can only have a reference to something to invoke it if you actually have a reference to it, you can only serialize yourself with a reference if you actually had access to that reference. So we run eval and apply backwards, asking the objects, okay, which things how are you going to serialize it? Well, how are you going to wake yourself up next time? Oh, and then you ask those next objects, okay, how are you going to wake yourself up next time? And then it basically serializes the whole graph, and it can save it to a database, and then we can actually restore it live. And so you can actually serialize a running program with all this behavior and state inside of it. It turns out you can also use that same mechanism to be able to do upgrade, right? Because when you restore yourself next time, you can actually add new code that says, okay, well, the next time this thing runs, it's actually going to do, that was on version 0, this is on version 1, and stuff like that. So we do have a persistence and upgrade mechanism. And partly thanks to Goblins' transactional heaps and stuff like that, it can even be made very efficient so that only the objects which updated get serialized and stuff like that. But yeah, we do have an answer to all that stuff. So it turns out that you don't need to actually write things down in your Django admin, where you write down this user can do this user can do that. Your runtime code stuff actually can encode all that type of stuff, and we can serialize it to disk and restore it, and even do upgrade over it.
So in that case, the object then, let's say that the object is owned by the king, and the fool says that is now mine, or something like that. You could have something in there that says, no, this is actually going to be part of the, this is going to be owned by the king. The scepter says, I'm owned by this particular king, and if I'm owned by somebody, then nobody else can have this unless they give it to someone else.
Scepter doesn't need to think of identity, right? Your key doesn't know who owns it in your pocket, right? Your key is just in your pocket, right?
Yeah.
So your scepter, your fool simply never had the scepter. So when your fool is serialized, your fool can't say I had the scepter, right?
Right.
Your king has a scepter, right? If your king hands the scepter to the fool, then the fool can say, "Ha, I have the scepter," and now the fool has the scepter, right? But the fool simply doesn't have the capability, right? So similarly, if you're in our system, if you wanted to have access to the file system, and you say, "Oh, I'd like to have access to that file system," yes, I have this little piece of code that was set up to I want to be able to I want to crypto locker this hard drive, but you were never given access to be able to do dangerous file system things, or maybe you're given access only to this one file. Right, you don't get access to the whole file system, right? You just simply can't get access to the whole thing. You can only get access to the pieces that you had.
Gotcha. Well, if there's no other questions, any questions? Questions?
Did people have fun? Was it
I
even
did.
fun? Okay, good.
Yeah.
I know it kind of lagged in the middle there when I was like trying to code that thing live and it wasn't working. But
Yeah, I mean,
that was my favorite part.
okay, good.
I've been there giving presentations when things don't work right, and that's anybody can give a presentation that works well.
yes,
It's fun when things don't.
exactly.
Okay,
And you did very well at it.
good. I'm glad that was the case. I'm sure I'm going to watch this video later and be like, oh, of course, that was a stupid thing I did that made this whole thing fall apart in the middle. But that's actually that is what it's like developing something, right? You're trying to figure things out piece by piece, and I think one of the things that's really nice about Goblins and our mechanisms for programming is that programming Goblins feels like exploration, right? It feels like something that's alive, right? We really want something that feels alive. If we wanted to show off, if we wanted to throw in something for one more piece of time, you know what? We shouldn't do that. That's
We're
we've only
running
got
out of
15 minutes.
time, unfortunately.
Yeah. Okay. And what we really should do is in the future when we have the OCAP safe mud that people can extend live while they walk around it securely. We should do a future presentation where the audience actually joins us in, and we actually do a presentation where we kind of like the old mud presentation that I gave before it was OCAP secure. So one of the inspirations, I'll say this as kind of a closing remark. So I made this look very video gamey, and that's because video games are a great way to test out systems and feel fun and enjoy it, right? Spritely's ambitions are a lot more serious than video games. We're not just trying to make video games. But of course, video games are a great they're a great thing to deliver, right? They're also a great way to feel motivated while you're working on very serious components, right? Being able to build the thing that was rock solid enough where you could build a distributed bank on it. The way that I built the core components, though, is I made a video game first because that was a lot more fun, right? And actually, one of the things that led to Spritely is I did make a multi-user dungeon. It's like a multiplayer text adventure thing that people could play a number of years back, and I even gave talks where like each room in the mud was actually what I used for the slide. And everything was interactive. You could play with this gadget over here. You could do this type of thing, and people would say, "Oh gosh, wouldn't it be fun if this room had this?" And I would add it right to the thing, and then people said, can I add some objects? Can I program some cool code? And I am like, ooh, if I let you do that, then you'd be able to pwn my system, right? You'd be able to delete my files and all these types of things. And people are like, well, could you make it secure? And I'm like, I don't know how, right? That was partly the journey that led me down. How do I figure out how to do all this stuff? So being able to do things with, so I guess the last meta comment I'll make is there will be some game things that will not be Spritely's core focus, but they will help us understand what we need to build to be able to make Spritely's core really rock solid, right? So I guess that last thing is the role of fun in doing something serious, right? I think the role of fun in doing something serious is that fun things make boring things understandable, right? And they make it you willing to walk through, do all the work to be able to make something really significant. Yeah. So that's my fun advocacy there at the end of this talk.
Excellent. We posted the comment card, so if you would please fill that out. I know some people filled it out very early on. If you want to change any of your answers, I think it'll allow you to do that.
After I got my code working? Yeah.
Anywho, Jim, we don't necessarily have anything set up for November. Oh, first up, thank you so much, Christine. I neglected my manners. Thank you so much for coming out and presenting. This is awesome.
Yes.
Thank you for having me.
Thank you so much. Jim, do we have an idea or an inkling of what's coming up?
We don't yet.
Okay. All right. We will have inklings very soon, and
we'll have something
posted to the website as soon as possible.
Yeah.
Okay.
I can volunteer for a future talk, but probably not next month.
Yeah, no, it's perfect.
Yeah.
And I know a lot of folks, I know their brains are probably breaking learning all this stuff, especially, seeing someone who's expert at Scheme and running through all that stuff. Scheme is a very interesting language. You're part of the reason that I actually learned Scheme. And I want to get back to it. I'm looking through the season schemer, and Eventually, I'll make it to later chapters in that book.
Yeah,
Oh,
it's
nice.
a
I'm
bit of a
actually
slog.
also only at early chapters of the Season Schemer. Little Schemer, I made it through, but not
Sorry,
Season
Little
Schemer.
Schemer. Yeah, the Little
Oh,
Schemer.
okay.
Sorry. Yeah.
Little Schemer's a ton of fun. So,
Mhm.
that's a thing I forgot to plug. And
Okay.
actually, I really should plug it. If you thought this stuff seemed cool and the scheme stuff seemed tantalizing, here is a thing that, am I still screen sharing? I think I am.
You are, yes.
So let's go to, on Spritely.institute, there's another thing. If you scroll down to the news, there's this thing that says Spritely Institute publishes a scheme primer. We really need a better page to collect all these papers. But if you click on this, this is starts with no assumption of any programming background. Or if you have programming background, it says, okay, well, if you only know Python or JavaScript, that's fine. We'll just, tell you what this is like, right? But and it teaches you starting from no previous experience in Scheme or Lisp or anything, and in 30 pages of code, it compresses about 3/4 of one of the most famous books in computer science, Structure and Interpretation of Computer Programs, I argue. And quite a few people have told me that they actually learned quite a lot from this tutorial. And what's amazing is that in 30 lines of code, 30 pages, if you print it out, it's only about 30 pages. At the end of it, it ends with the big finale is Scheme and Scheme. Here it is. Here is a implementation of Scheme written in the programming language of Scheme in 30 lines of code. And it only takes 30 pages to get to that. So if you are willing to read a Scheme primer, by the end of the paper, you will actually get to how to write a Scheme interpreter inside of Scheme in only 30 lines of code. And that is the opening to understanding how programming languages in general work. And not only that, but the interpreter you will write is OCAP secure. And so that's it. That's the real end of my presentation. Read a Scheme primer, implement Scheme in Scheme, spend a weekend upgrading your programming skills. All right, that's it.
And upgrading your brain.